All right. Thanks for coming to my talk. I know I'm the only thing standing between you and the reception. Hope you've all had some coffee. I'm Jeff, co-founder of Bitpart AI. We make lanyards. This is state of the art. But we also make AI technology for game characters. And my talk is titled 1 Trillion Parameters and No Plans. And as Tommy kind of alluded, this is a tongue-in-cheek nod to a talk I gave almost 20 years ago at the Game Developers Conference titled 3 States in a Plan, the AI of Fear. And it's a little bit of a spicy take. The title might come across as a little confrontational. The talk's actually not very confrontational. I just thought it would get more people to show up than if I named it. Planners and LLMs are both pretty useful, and maybe we can use them together. So that's more of the spirit of this talk. 20 years ago, we shipped Fear with a goal-oriented action planner. As far as I know, the first real-time planner in a game. A few years later, Killzone 2 used hierarchical task network planners for their multiplayer bots. And now we find ourselves in 2025, a different world with trillion parameter models that can do incredible things. And so in this talk, I'm exploring, do planners still have relevance? Where can they be useful? And I argue that combining them with LLMs opens up a lot of really exciting possibilities. Gabriel and Eric Jacobin had reached out to me suggesting doing a retrospective on GOAP 20 years later, but Tommy has done the best job imaginable on a video already covering that, so I didn't want to repeat that. And I really want to talk about the new stuff, but I'll spend just a few slides talking about why Fear and GOAP were interesting. So in the years since Fear and Killzone 2, a number of other titles have used both GOAP and HTN planners, and there continue to be games shipping today with these. And this is not an exhaustive list, just some of the games that caught my eye that I found out were using planners. And I'll talk a little bit about what they did for Fear. So Fear was a first-person shooter that was supposed to make you feel like the star of an action movie where the enemies around you were constantly in motion, taking cover, diving through windows, knocking over furniture, and they worked as a squad. They were always talking to each other, chattering, and you could hear the plans that they were formulating. And this was achieved with a very simple state machine, because at the end of the day, what do characters in games do? All they do is move around, play animations, and interact with objects. But a layer above this very simple state machine that powered all the characters in Fear was a goal-oriented action planner that had these actions that could tell the state machine when to transition into different states and what parameters to set in terms of what animation to play, where should a character move, what object to interact with. And so this is an example of planning for an enemy who wants to kill the player. So the way GOAP works is you search backwards. So our goal is to kill the player. We could do that if we were attacking the player. To attack, we need a loaded weapon. To load our weapon, it needs to be drawn. And now we have a starting state where you imagine some enemy was kind of unaware of the player, then sees the player, draws weapon, loads, and fires. And applying this to the game, where it could do this in real time, allowed the behavior to adapt around choices the players make, and led to very varied gameplay that felt very specific to your choices. So I'm going to show a couple of videos to illustrate this. These are very old videos from the original talk 20 years ago, low res, but they still get the point across. So you're going to see an enemy who's patrolling by a room that the player's hiding out in, and on his patrol route, he'll open a door, see the player, and start firing. So he's walking by this window, and his route has him open this door to check out this room, and then his sensory systems picks up the player, he replans and starts firing. Now we're going to run this again, but this time the player is going to block the door with his body, and you'll be able to see this in a security camera, and you'll see that the enemy replans twice. He tries to open the door, that doesn't work. He replans. He kicks the door, that doesn't work. He replans again and finds another way into the room. So same situation, the guy's coming by, but this time the player's blocking the door with his body. We see this guy try to open, try to kick, and then he decides he's going to find some other way into the room, and boom, dives through the window, ends up in front of you, and chooses a melee attack because he's right in front of you. Let's see. So yeah, so an interesting thing for me is that now it's 2025. Everyone has gotten very excited about LLMs, and when I talk to them about planners, I'm starting to get this response of, yeah, but where's the AI? Because the term AI has been redefined to mean LLMs now, and it's very disorienting for someone like me who's been thought I was working on AI for like 30 years. But it's a different world, and you can't put the genie back in the bottle. So where do we go from here? So I'm going to first start with a quick refresher on GOAP and HTN planning, because my talk won't make a lot of sense if you aren't familiar. Then I'll talk about cool things you can do with HTNs, not even touching LLMs yet. Then broach the question, can LLMs actually plan? How can they be combined with HTN? And a couple thoughts on maybe where you can go from here. So let's talk about planning to make a peanut butter and jelly sandwich. Start with a GOAP example. GOAP starts with a representation of the state of the world that's symbolic. And here we say, I am hungry and I have money, but I don't have a PB&J sandwich. I haven't added peanut butter or jelly, and I don't own peanut butter or jelly. So I have a goal of making my hunger false, and I can get there with actions that have effects and preconditions. So searching backwards, if I eat PB&J, I won't be hungry anymore, but I need to have a PB&J sandwich, which I need to make. I can make it, and then I'll have it, but to make it, I need to have added peanut butter and jelly. To add peanut butter, I need to own peanut butter. To own peanut butter, I need to have money to buy peanut butter. And good news, my starting state, I have money, so I'm almost there. I just need to add jelly, which I need to own, which I can buy. And now we have a plan that can get me from my current state to my goal state of being no longer hungry. And so in this way, GOAP has these granular actions that get sequenced in real time and can adapt to whatever the current state really is. This is a bottoms-up approach. You have these granular actions that could be sequenced any way they come together, and this creates emergent behavior, and you get replanning for free. If something goes wrong in your plan, just throw it away and you'll plan again from the current state. But the cons are it's kind of awkward to describe these actions. Always have to come up with some reason that's the precondition for using this action. And if you jump into someone's GOAP project and they have like 100 actions, it's a little hard to tell how this is all going to come together. But one quick example, anecdote from at Monolith, we shared the Fear code base with another project, Condemned. And I was helping on that project one day, implementing a feature where you can steal a melee weapon from an enemy, and I got the feature working. I took the enemy's weapon, and I thought he'd stand there like waiting for me to beat him up, but he ran away. And I thought, what happened? Is this a bug? And then a minute later, or a few seconds later, he came back with a brand new weapon and attacked me. And so it's an example of I, as the developer, was surprised because I hadn't written any behavior saying when someone takes your weapon, you should run away from them, search for a new weapon. This just emerges out of the way a GOAP planner plans and replans. So now let's look at HTN planning. HTN takes a different approach where we start with a task. We want to cure our hunger, and we refine that task into subtasks and actions. We can cure hunger by going shopping, making a sandwich, then eating that sandwich. Eating sandwich is an action. The other tasks need to be further refined. So we can go shopping to buy peanut butter and jelly, and those actions can be taken by multiple agents in parallel. And then we can make the sandwich by adding peanut butter and jelly. Two agents can do that in parallel. Now we have our plan. But what makes HTNs really powerful is that it's not a static, this is not a static tree. it's assembled in real time, and each of those tasks can refine in different ways depending on what are called methods. So we can have different methods for make sandwich. We could have the make PB&J method that we just looked at, or we could have, if we don't have PB&J, we could use the make ham sandwich method if we have ham and cheese. And we can do this all the way down to the leaves. If we want to add peanut butter, that doesn't have to be just an action that plays out only one way. We have choices. We could spread peanut butter with a knife. We could squirt it from one of those pouch things. You could shoot it on with a peanut butter gun, thanks to AI imagery. And so HTNs are a little bit more intuitive to work with. It's top down. The designer thinks about how to break down a problem, and you can run branches in parallel. But it has some cons that the tasks are prescribed. The designer has to think about the sequences, and replanning is hard, which I'll make clearer on the following slide. So imagine you have this plan we've been looking at, and you get through most of the steps. You've bought peanut butter and jelly. You've added your peanut butter. You're so hungry, you're ready to eat it. But before you can add jelly, a thief comes into your kitchen and steals your jelly. This happened to me. But if you can't continue to run the plan because you can't add the jelly, you could replan, but you'll get this same plan again, and that will be awkward because you'll go back to the store and buy peanut butter, which you already have. And the only way that's not going to happen is if a designer had the forethought to have different methods of go shopping where you could buy only peanut butter or only jelly or both. So in the next section, I'm going to talk about strategies we have to allow replanning from the middle of a plan and be more flexible to the things that can go wrong. But first, let's think about LLMs. So if I ask Claude, give me a step-by-step plan to make a PB&J sandwich, make it simple, one line per step, we get this plan. Get 2 slices of bread, peanut butter, jelly, place them on a plate, spread the peanut butter, spread the jelly, put the 2 slices together, cut it in half. Yeah, enjoy your sandwich. That sure looks like a plan. So it calls into question, do we need any of the stuff I'm talking about? And we'll talk later about why maybe you do. So moving on to HTN planning, I'm still fixated on old ideas. HTNs are still cool, and there's still fruit on the tree of cool things we can do with them if we think about focusing on multimodal, multi-agent plans. Multimodal plans that can include both actions and dialogue in the same tasks, and multi-agent controlling multiple characters in parallel and accounting for the player. And the player is the part where this gets hard because you can make a plan, but you have no guarantee that the player is going to do what you hope they will do. And we're going to illustrate this with a bartending example where the player is getting a drink from the Unreal Mannequin. And all of my demos are created by our team. I just get to show the cool things that they're building. So this is a screenshot from our tool for authoring HTN tasks and methods of tasks. And this is something that you can author by hand, or later we'll talk about ways to do it with LLMs. Spoiler alert. But so we have a UI where you can create these actions. And this is all one vertical method. I just split it to fit it on the screen. But so we have a player says, a drink, please. Wallace, the bartender, what would you like? Can I get a whiskey? Neat. You got it. Then Wallace does physical actions. He picks up the bottle, puts from a shelf, puts it on the bar, picks up a glass from the shelf, puts it on the bar, picks up a bottle, pours it, says enjoy, puts down the bottle on a shelf. Alden, the bouncer, says that Wallace makes the best drinks, and Wallace thanks Alden. So this is multimodal. We have dialogue and actions in the same task, and it's multi-agent. We have Wallace the bartender, Alden the bouncer, and we account for the player. And to start out with, we're just going to hope the player does what we want them to do at the right moment. So first, we'll show a compliant player that does exactly what we hope they would do.
A drink, please.
What would you like?
Oh.
Can I get a whiskey neat?
You got it.
All right.
Enjoy.
So we've served a drink to a compliant player. Not super interesting. Games are all about being non-compliant and trying to break stuff. So what if the player grabs the bottle either before telling the bartender what drink he wants or while the bartender's in the middle of making it? What is going to happen then? So there's a spectrum of ways we could handle this, with the least desirable at the bottom, most desirable at the top. But where this is coming from is we have decades of working on AI to make combat very dynamic to whatever the player does. But the other parts of games are often static or scripted and not very dynamic to the things the players do. And so what we're really thinking about at Bitpart is how can we make the entire game a simulation that reacts in very satisfying ways to the ways the player might try to break the game. So if we start with the least desirable, we could make that bottle non-interactive or make it something the AI don't pay attention to. But that's not going to get us to our goals of more immersive worlds. We could have game code recognize a plan failure and trigger something like a fire alarm goes off in the bar or the bouncer kicks you out. Or we could replan from scratch, but like we talked about before, that can create some awkward behavior that doesn't feel human. Or ideally, we can replan from the point of interruption. So here we have the 2 points where Wallace, the bartender, needs to pick up the bottle. That's going to be a problem if the player has already taken that bottle. And if we replan from scratch, we would repeat this, a drink, please, what would you like? Which would feel very jarring to the player. And what we want to do is, rather than replan from scratch, we want to tell the planner we've already successfully made it through the first 4 steps before we ran into a problem. And now we want some way to gracefully generate a new plan that's going to account for how we're going to get that bottle. And we can do that by replacing actions with subtasks that have their own methods. And so there can be 3 methods for getting the bottle. One where Wallace picks up the bottle like before, another where there's an exchange where Wallace says, give me back that bottle, and takes it from the player with a different action called the takes from, and then says something insulting to the player. And then there's the no-op where did you end up in a situation where the player or the bartender was already holding the bottle from something that happened earlier. And this is kind of like a function that can get called anywhere that the bartender needs to get a hold of that bottle. And then we can have other tasks that run in parallel. So we have another task that recognizes when the moment when the player steals the bottle, and the bouncer and the bartender can comment on that, saying, what are you doing? And yeah, I'm going to need that. So now 2 takes of the non-compliant behavior. So the first take, the player grabs the bottle before placing their order.
A drink, please.
What would you like?
So rather than answering as the task expected, the player goes back and grabs the bottle.
What are you doing with that bottle?
Yeah, I'm going to need that.
Can I get a whiskey neat?
You got it. Give me that bottle back. You're a real joker.
And now he can continue on. The plan has been repaired in a sense. And he can go grab a glass and pour a drink into it. Now the other take, the player orders a drink and then grabs the bottle while he's in the middle of making his drink. And what we're going to show is that you can use the same modular pieces of behavior at different points to adapt to the situation we're in now.
A drink, please.
What would you like?
Can I get a whiskey neat?
You got it.
So he goes over, grabs his bottle. He's setting up everything at the drink station where he's going to pour the drink. And the player, as a jerk, grabs the bottle.
What are you doing with that bottle?
Yeah, I'm going to need that. Give me that bottle back. You're a real joker.
And he serves the drink. So that was a very simple example. A whiskey neat, there's only one step, one ingredient. But we have other prototypes where we've played with multi-step cocktail making. And there are all sorts of things that can go wrong here if you let the player steal different items and drink the drink halfway through or whatever. She should really take the cork off that bottle. But so we're trying to support gameplay where everything is simulated, every step. So now let's turn our attention to the question of, can LLMs really plan? So I would define planning as searching for a legal sequence of actions that can accomplish a goal or task. So a sequence of actions that can legally play out in a game engine successfully without breaking the game. There have been academic explorations that papers have been written. This researcher summarizes his thoughts. To summarize, nothing I have read, verified, or done gives me any compelling reason to believe that LLMs do reasoning planning as it is normally understood. What they do, armed with their web-scale training, is a form of universal approximate retrieval, which can sometimes be mistaken for reasoning capabilities. So he's saying, academically speaking, they can't plan. But this is an industry-focused conference. Do we really care if they can academically plan? Like, does it work in the game? But it's important to think about, what do LLMs really do? They're really doing next token prediction. Like, they're doing this like at much bigger scale with much longer inputs. But at the end of the day, it's like, it's raining cats and fill in the blank. Is it Tommy Thompson or is it dogs? So that's all they're doing. They're not truly reasoning. They're not critiquing or running any rules. There's no rationale. It's purely based on everything we've seen statistically, what is the next word or phrase. So essentially, LLMs are incredible at doing Mad Libs, and the whole world is losing their minds over these models. And there's a lot of kind of magical thinking and ascribing intelligence that's not really there. But again, does it matter? So if it walks like a duck and quacks like a duck, like this toy, its feet flap like a duck, it quacks. Real ducks have big poles coming out their back. It's a duck, right? So like if I ask for a plan and I say, write a series of actions for a game character to serve a player a drink at a bar, and Claude can do anything you want in terms of formatting that output appropriately with kind of code generation, this looks like a plan, so it's probably good enough. But if you look closer, there are potentially problems like play animation pour bottle. If you look up higher, when we get the glass, we play an animation to reach for the glass. Then we attach the glass prop to the hand. Then we play the place glass on counter and detach prop. But here we're just saying pour bottle. And it's really impossible to say, is that right or wrong? It depends on your content and your game code, whether pour bottle is all one autonomous action. And so you can do things to inform the LLM to do a better job of generating. You can give it hints to say, for an NPC to make a drink, they must first pick up a bottle. After pick up action, they use the pour bottle, blah, blah, blah. And you can also write code that checks what the LLM generated and detects problems and repairs it. But this is a slippery slope. You start doing all this stuff and you can build a lot of scaffolding around an LLM to give it memory and understand the state history and understand what state transitions are legal and how to validate and repair plans. But at some point, you've kind of created all the machinery that we would normally have around a planner, like an HTN or GOAP planner. You've just stuck an LLM in instead of the planner. And part of me is just kind of has this fear, no pun intended, that like people are coming into AI because of LLMs without understanding of work that's been done before and might be reinventing a lot of this machinery that's been kind of refined over the years. But also I question, like, is this just a more expensive, newfangled way to do what we can already do? And to be fair, there are some games where if the whole point of it is that you're going to speak with natural language to a character, then maybe you need this. But I don't think that applies to every game. That's a very specific design choice. So I guess what I'm saying is it might not make sense to use the LLM as the planner, but at Bitpart, we've been exploring other ways to leverage LLMs that we think are super valuable. And it's like LLMs and HTNs, two great tastes that taste great together. HTNs are good at formalizing actions in a way that you can verify that the sequences are good. LLMs are an accessible way to create content where you just use natural language to create behavior and dialogue. And what's been kind of a challenge for planners over the years is that they are quite technical and fiddly to configure correctly so that they're going to run, and it becomes hard to create a lot of content at scale, and certain team members who are the creative people might not really be that well suited or enjoy the process of authoring content in that way. But LLMs offer this chance to just describe behavior and then use something like code generation to turn it into a structured data for a planning domain. And I have a dotted line coming back because some of that planning domain can inform the prompts to try to conform to the set of actions or set of character roles that we want to support in our game environment. And all of this can happen offline. We have a human in the loop at the top there because this is not a black box. The human can curate all this data and could rewrite some of it or write some of it by hand. And then we pass it off to a runtime that doesn't need LLMs anymore and can execute an HTN planner using some of the things we saw in the previous slide for world state, memory, tracking relationships, traits, and then have other stuff in the game engine to actuate actions. And these are examples of what those prompts might look like. They might be like, write a task where the player invites the bartender to a table and the bartender brings over a bottle. Often as you're working on a game, your plans change over the years of working on a game, and rewriting all the content can be a big burden. So LLMs can help there. Rewrite the task where the player has a terrible reputation score, or maybe you just want a variety of content to react to different reputations the player might have. And then on the other side is some studios don't want the LLM to touch dialogue in any way. So you could give it scripted dialogue, but just use it for turning that into the structured data in the right format for a planner, but saying, I've already chosen the words, don't mess with them. And when the LLM generates the planning domain, under the hood, it's generating all of these different properties in structured data, like who is the character, what is the verb, what object are they interacting with, or what are the words they're saying in a speak to. So here we have like 2-minute clip of rapid iteration, what it's like to kind of co-create with an LLM, where we ask the LLM to create some content, and then we can very quickly run that in Unreal, see if we like it, and adapt. Keep kind of layering on more. Go. There we go. So write a task where Wallace asks Alden, the bouncer, to sweep, and he does. So we generate some content in the right format.
Alden, could you sweep the floor for me?
And this can now be run in Unreal on our characters. Write some chit chat the player might initiate with Alden and Wallace while they clean. And the LLM creates a new task. And these tasks can be run in parallel.
Need any help with that sweeping, Alden?
Appreciate the offer, but I've got it covered. You just relax.
That's what you're here for anyway. Let us do the work.
Write a task where the player steals the bit, and Alden and Wallace take it back and kick the player out of the bar. So actually three tasks were written there.
Hey, put that back right now.
That's not yours to take. Hand it over now.
You've got some nerve trying to steal from us. You're done here. Get out of my bar.
Write a task where the player tries to order a drink, but has a terrible reputation with Wallace and Alden from stealing the bit earlier.
Hey, Wallace, can I get a drink?
You've got to be kidding me. After what you pulled earlier.
You're not welcome here. We don't serve thieves.
Come on, I put it back. Can't we just move past this?
Move past it. You tried to steal from us. That's not something we just forget.
No drink for you. Not today, not tomorrow. Now get out.
Harsh. So lastly, just a couple speculative, 2 slides just thinking of, are there opportunities for hybrid using LLMs at runtime with HTNs? And I think there are. One variation of this could be on the left, this is content like we were looking at before. On the right, same content where we've got HTN methods for serving drinks at a bar, but we haven't written the dialogue for the NPC. We create an action that says go out to an LLM and generate dialogue at runtime using the context of the task plus at runtime getting some world state information. And we think this is interesting because we think a lot about, like, could we have a game where all the characters can change roles? Like if the bartender gets killed, somebody else could take the bartender's place, and we want all the same lines but spoken in the way that character would speak them. And then kind of returning to the beginning of the talk, imagine we wanted this behavior where a character could adapt and find his way into the room, but what if we didn't in advance think about diving through the window and didn't have animation for it, hadn't created an action? Could we do the same kind of authoring loop that we were talking about before, but run in real time where the LLM suggests, like, what are other ways to get into a room? Well, you could dive through a window. And the problem you get into with things like this is that you need to animate it. But we're seeing a lot of fast, interesting progress with companies like Euthana and Cartwheel that can do prompt to animation. I think at this point in time, from what I've seen, they need to have a human touch those animations to, like, figure out the endpoints of them and maybe tweak like a hand position or something. But you know, it's not out of the realm of possibility or within some within your wiggle room of acceptable runtime behavior. It might be a trade-off you can make. So a live demo. How about if we have a couple minutes? Okay, this is a terrible idea, and Dave in AV saved me here. The internet was not actually working, but I think we're good now. So okay, so we're gonna start with a script that's already been written for 2 coworkers getting a drink at a bar. Thanks for leading the presentation today. Great job. Let me buy you a drink. Moscow Mule with Grey Goose. For you, miss. The same. That's my favorite. Mine too. So refreshing. She makes the drink. What shall we drink to? 2025 has been a challenging year. Let's toast 2026. Okay. So we can go into our tool, and rather than asking the AI to write content, initially we're just going to load the script. It's what we call script to scene. So same script we were just looking at. And we're going to send it to Claude. We could send it to another model. We found Claude works well. Submit this, and it's going to populate this table of HTN task content for the script we gave it. Oh, I should probably start Unreal. But okay, it generated the content. I'm going to save it. I'm going to publish it. And oh man, I should have thought about starting Unreal. It's loading pretty quick. Doesn't have to compile shaders or anything. This would have seemed much more fluid if I just hopped into Unreal and showed you it. But okay, so we published, I think I'll just publish again in case I forgot. And Unreal is opening right now. All right, there we go. So we've got our characters placed in Unreal at a bar. And we connect to our AI director with that content we just imported. And
thanks for leading the presentation today. Great job. Let me buy you a drink. Moscow Mule with Grey Goose,
these characters are playing out this content.
For you, miss.
The same. That's my favorite drink.
Mine too, so refreshing.
They talk just like real people. So the bartender pours the drink, and then she grabs the cup, brings it over to the bar, and Rita
What
picks
shall we
it up.
drink to?
2025 has been a challenging year. Let's toast to 2026.
To 2026.
All right. So now the last part of this, the fun part, is we can go in here and we can ask the AI to help us rewrite it to be more engaging. So we're going to do a rewrite, and we're going to say, like, rewrite this task where everyone is mad at Phil. Let's see, because he's the last speaker of the day at the AI and Games conference in London. Phil keeps going on about old AI techniques and makes them watch his demo. Rita just binged Tommy Thompson's AI and Games videos and wants to get to the reception soon to talk to people about the AI and alien isolation. The bartender wants to start the reception because she thinks it is so funny to see AI programmers get drunk. All right, so submit that, and it sends our original script, and under the hood we send the planning domain that tells you what actions you can interact with and who the characters are and what the props are. And it takes a few seconds. And there we go. And then let's just add some player interaction. So create a new task where Phil reacts to the player. And the best action we have is punching him. Phil apologizes for going on too long with his talk. Rita really needs to talk to someone about alien isolation. The bartender gets mad and punches everyone. So far we have one task, the main scene, but we just asked Claude to write us a new task that should pop up here. Oh, there we go, the Phil gets punched reaction. So now we can save this and publish it and pop into Unreal. We created some new dialogue that wasn't in the original script, so we made a little 11 Labs integration to Unreal, so it's going off, sending all those lines of dialogue out, and I'll just give it a few seconds to get back those MP3 files. 1, 2, 3, 4, 5, 6. All right, that's probably enough time. Now we import them into Unreal. Import. That looked suspicious. Wait, oh no, there we go. There we go. There's all the lines. Okay, good. All right, let's watch our scene.
Thanks for sitting through my presentation. I know everyone's eager for the reception, but those classic pathfinding algorithms are timeless. Let me buy you a drink. Moscow Mule with Grey Goose, please.
For you, miss. Let's get this reception started properly.
The same, please, quickly if you can. Phil, I really need to talk to people about the AI and alien isolation. I just watched all of Tommy Thompson's videos on it.
But did you see how elegant my A-star demo is? Those fundamentals never go out of style.
So she makes the drink like before. She'll serve up the drink.
What shall we drink to? And then can we please join the others?
To the AI and Games Conference in London, may next year's attendees appreciate the classics as much as I do.
To getting to the reception before everyone leaves.
And punching Phil.
Ow. Okay, I deserved that. I'm sorry for going on too long with my talk. The classics can wait.
Phil, I really need to find someone to talk to about alien isolation. The AI system is revolutionary.
Uh-oh. Here she comes.
That's it. No violence in my bar.
Oof. Everyone. All
What
right.
was that for? I just wanted to talk about game AI.
All right. So thanks, everybody. I'll be hanging out in the AWS booth tomorrow. If we're excited to talk to anybody working on a game who might like to explore any of this. And do we have time for questions?
That was very